All right, welcome back to The Explainer, quantitative analysts and algorithmic traders. Today, we're essentially putting on our lab coats and treating the market like a crime scene. And the victim? Well, it's a blown-up algorithmic trading account. We aren't just going to sit here and talk in high-level theories today. No way. We're going to slice directly into real-world, highly granular Bitcoin gap data to uncover exactly what standard backtesting gets so dangerously wrong, and more importantly, how a rigorous methodology can finally fix it. Okay, let's dive right into this fundamental flaw that's plaguing the modern trading industry. There's this massive, almost systemic obsession with a final percentage return of a backtest, right? But the actual experimental conditions that produce those numbers, they're completely ignored. If I tell you a system made 40% last year, that number is entirely meaningless if I can't prove exactly how the data was handled at the microscopic level. I mean, think of how easy it is to tweak just a few parameters. Nudging a moving average here, ignoring a messy data gap there, just to make a backtest show a massive gain. Millions of dollars are lost every single day in the live markets because the underlying machinery of the system was never actually validated. You absolutely have to validate the machinery, not just the glossy final product. So here is our roadmap for the explainer today. First, we'll cover the backtesting illusion. Second, defining the data set. Third, sequence and market structure. Fourth, classifying gap behavior. Fifth, reproducibility versus validation. And we'll wrap up with the SRBMPR principle. Let's kick things off with Section 1, the backtesting illusion, going beyond the final percentage. You've got to think of the financial market exactly like a strict physics experiment. If a physicist claims they discovered a new subatomic particle, but then they just threw away the temperature, pressure, and chronological sequence of their experiment, their outcome would be thrown out of peer review immediately. Can you imagine a scientist keeping their job after saying, "Oops, I just accidentally deleted the days the particle didn't do what I wanted"? No way! Yet in algorithmic trading, isolated numbers are thrown around and bad data is glossed over constantly. It's a total curve-fitting illusion. True market behavior research requires a strict, predefined pipeline where every single step, from input to result, remains entirely traceable and structurally sound. Moving right along to Section 2, defining the data set, which is really the foundation of all our evidence. And this brilliantly illustrates just how strict the SRBPR framework really is. Rule number 1 demands that before we even think about executing a hypothetical trade, we must rigidly lock down our evidence. The original dataset has to remain absolutely unchanged during verification. We need the exact asset, the exact time frame, the precise time zone, and the exact count of observations. Now, you might be wondering, why does this level of pedantic detail even matter? Well, consider this. Something as incredibly simple as a daylight savings time shift in a poorly defined time zone parameter has historically ruined millions of dollars in automated trades. Why? Because the algorithm entered trades an hour early. If you and I are testing the exact same strategy, but my dataset has missing historical ticks or a different time zone offset that yours doesn't, we're simply no longer running the same experiment. Let's look at a specific case here. Notice Gap ID 1 from July 20th, 2024. The data clearly shows a missing count of 130 observations on a 10-minute time frame. Let's put that into perspective for a second. That is over 21 hours of market movement completely blacked out. In a loose, amateur backtest, this gap might just be smoothed over, interpolated, or entirely ignored just so the system doesn't break. But under our framework, we meticulously flag this as high side info missing. We have to precisely track exactly what information is absent. If a 10-minute gap with 130 missing data points exists, your algorithmic engine must acknowledge exactly what blind spots it's operating with before it can validate even a single simulated trade. All right, Section 3, sequence and market structure. Because when it comes to data, chronology is king. So the crucial point here is that market events are not just isolated numbers floating around in space. Their exact chronological sequence is vital evidence. According to SRBMPR Rule 2, changing or losing the sequential relationship completely invalidates the experiment. If you hit a market gap where both the high and low side information are missing, you have what we classify as an unverifiable order. Think about this practically for a second. Have you ever backtested a strategy and just kind of assumed your stop loss wouldn't have been triggered during a massive weekend gap? Well, that assumption is an unverifiable order. You literally cannot prove the sequence of price action during that void, which means your backtest result for that specific trade is entirely fictional. We can actually see this condition explicitly triggered for gap IDs 16 and 17. Both of these occurred in September 2024. Both have 6 missing data points, and both are flagged with both high and low info missing. Let me slow down here because this is absolutely critical. Our methodology treats this chronological structure as non-negotiable. A gap with missing high and low information is basically a black box. You know exactly where the price started before the gap, and you know where it ended after the gap. But the journey inside, it's a total mystery. You just can't retroactively guess the path price took through that void just to make your backtest look a little bit better. Next up is Section 4, classifying gap behavior, or why we need to predefine the rules. So Rule 3 of the methodology mandates that you have to establish your behavioral classification rules well before you ever interpret a final result. Are we looking at a retest, an expansion, a higher high, or maybe a lower low, a zero cycle? By predefining the left side and right side behavior of a gap, you completely eliminate the temptation to retroactively decide what a market move actually meant. Without these locked-in definitions, it is incredibly tempting to look back at a losing trade in your backtest and say, oh, actually, scratch that, that was just a retest, my algorithm wouldn't have taken that. Setting these rules in stone eliminates the temptation to bend the facts simply because you want to keep your funding. Now, what's really interesting about this is how rigidly it gets applied in our 1-minute gap behavioral report. Take gap ID 4, which happened on April 29, 2026. The pre-gap direction was moving UP. Because of our strictly predefined rules, this mathematically dictated a long hypothesis bias. And the measured outcome? A reversal. Conversely, check out the mechanics of gap ID 10. The direction going into the gap was strictly flat. Well, because of our established rules, a flat trajectory results in no hypothesis bias at all, and therefore the outcome is permanently locked in as NA. The logic here is entirely mechanical. It doesn't care about your feelings, and it was defined long before the outcome was ever measured. All right, moving into Section 5, reproducibility versus validation. This is a crucial distinction. These are two completely separate research questions, and blurring them together really ruins your credibility. Reproducibility means taking the exact same defined data set, like our Bitcoin gap logs, and applying the exact same predefined methodology to see if you get the exact same result. Validation, on the other hand, means taking that methodology and applying it to a completely different, unseen data set, like Ethereum or maybe traditional equities. Think of reproducibility as proving you can bake the exact same cake twice, using the identical recipe and the identical ingredients in the exact same kitchen. Validation is taking that recipe and seeing if it still works at a high altitude with a totally different brand of flour. Both are highly scientific for sure, but they are not the same test. You haven't reproduced an experiment if you changed the experimental material. Finally, Section 6, the SRBMPR principle. This is where we look at the complete pipeline. Let's see how this all builds into a beautifully rigid assembly line. It starts with data, acquiring the absolute locked-in evidence. It then moves to time, anchoring every single tick to a verifiable clock. Third is sequence, establishing that unbreakable chronological structure we talked about. Fourth is behavior, systematically categorizing every single movement. Fifth is rules, enforcing strict, predefined logic without any emotion. And it all ends with true reproduction. Every line of Python execution, logic, and every processing pipeline in your trading algorithm must flawlessly map to these exact 6 steps. It's like a chain. If a single link breaks, if time is ignored or sequence is assumed to be something it isn't, the entire chain snaps, and your experiment is compromised. Which leaves us with the ultimate reproducibility test. I want you to look at your own algorithmic systems and ask yourself, can another researcher reproduce your exact market experiment using the identical dataset, timestamps, sequence, behavioral classifications, and connections? If the answer to that is no, you aren't doing market science. You're just playing with numbers. And eventually, the live market will call your bluff. Thank you so much for joining me for this explainer. I think it's time to go audit those algorithms.